Hello, my dear viewers and listeners. I'm excited to bring an overview of a proposal which concerns Layer 1 and Layer 2 of the Ethereum ecosystem. In this episode, we are going to have a deep dive into the first roll-up improvement proposal, also known as RIP, in the Ethereum repository. If this interests you, stay with us. Welcome back to PEEPanEIP, a video series and podcast dedicated to Ethereum standards and implementation. This is episode 129 and I'm your host Pooja Ranjan. RIP-7212 precompiled for secp256r1 curve support is documented for roll-up and layer 2 projects. The proposal reached to the final status recently. We are joined by Ulaş Erdoğan, the proposer and co-author of this standard. Welcome, Ulas.
Hello, thanks for inviting me. I'm happy to be in this video series.
Ulas is a builder, has co-authored proposal 7212 and has been added as RIP editor. In this episode, we are going to explore what RIP 7212 entails, its impact on Ethereum scalability, and what's upcoming on roll-up improvement proposals. Before we get there, may I request Ulas to kick off today's talk with an introduction, how he found Ethereum ecosystem and what inspired him to be an author of Ethereum standard.
Of course. Hello again, I'm Ulaş. I met with Ethereum in 2019 by joining my university's blockchain society, which is ITU blockchain. It was the first year that I'm getting knowing about what is blockchain, how does some cryptocurrencies, Ethereum and Bitcoin work, and get to know about the community. In the first years, I was researching about some industrial use cases of blockchain. Then with a newsletter that I have started writing, then also I have wrote for 2 years, I realized that there is another world, which is an on-chain world on top of Ethereum, which touches our lives, our daily use cases, and it also has a different understanding of the life. And I directed most of my energy and focus on learning about Ethereum. It's including philosophical overview and technical overview. Then I grew up with my university society and I took lots of roles like president or board member for years. And it was the years that I met lots of friends in my society, and we are still building together with these of my friends. And after these years, I have joined some academical research in my university and building some self projects with Solidity and smart contracts. Then I have joined some DeFi and NFT projects as developer and worked them to build their protocols. And then now, I mean, it's for 5 years, but it was a very fast years for me. And now we are building Clave, which is a mobile-focused account abstraction wallet on top of zk-Sync. And we are trying to combine the Web2 and Web3 worlds in a common point, that we bring the application habits from Web2 and security and decentralization practice from Web3, and creating an app that we can show a real world use case with payments and investments on blockchain for the normies. And when we start building this project, we have seen some issues that we are seeing while utilizing some real world devices. And then we have started the first research phase of EIP 7212, which was a requirement of a precompiled contract. Then we met with some people from Ethereum Foundation, and they proposed us to turn this work into an EIP and show to the community, and I will dive into the details. And this video series was important for me to understand how EIPs or other type of proposal work, and how can I get in touch with the community and show our work and get some feedback and improve our proposal. So again, I'm happy to be here.
Pretty interesting, starting from University Blockchain Society to get involved into writing, following industrial use cases, and finally working on a project and documenting a proposal for Ethereum ecosystem is quite encouraging for many of the community members. Thank you for all the work over here.
Thank you.
We hope to learn more about Proposal 7212, which is a standard right now. So without further ado, let's peep in.
I have talked about myself, and if you want to reach me in some way, it's my username in mostly all of the platforms, and I would love to get in touch with you. And today I will talk about our rollup improvement proposal 7212, which presents a precompiled contract in secp256r1 elliptic curve. And before going into proposal, I will talk a bit about the elliptic curves and how are the elliptic curves for the Ethereum protocol, and how can we include more elliptic curves, and how can we utilize this kind of new elliptic curves in some use cases. And we all know about elliptic curves. It might be the origin of the blockchain, which we utilize to prove any type of ownership in blockchain with some key pairs. And with this elliptic curves, we have our private case and public case, and we are signing our transactions and any type of message, then we utilize them to prove the ownership. And there are lots of various elliptic curves which differentiate on different type of parameters, their types, their styles and use cases. And I have talked about some private key and public key. It's a general use case of how we can utilize it in different type of blockchains to prove ownership, signing a message, then recover the signature to see who signed this message, then execute any function or maybe transfers in blockchain. And we will mostly talk about two type of special elliptic curves in this call. The first one is the K1 elliptic curve. It has most of the similarities with the R1 elliptic curve, which we have proposed as a precompiled contract. And the only difference of these two elliptic curves are their curve parameters. You can see that the two parameters of the K1 curve are 0 and 7, which has been chosen manually, and also they have some gas cost efficiencies, performance efficiencies in most of the cases. And you can see that the R1 elliptic curve has different curve parameters, which they are differentiate in type of the private case, public case, and signatures. And there are lots of rumors that when the generation of the R1 elliptic curve, it's standardized by NIST. It's a standardization institute in the US. And in the first days of elliptic curve selection during the creation of Bitcoin, the builders team didn't trust on these curve parameters and make sure that the Bitcoin protocol doesn't rely on any type of human effects. And if this R1 elliptic curve has any type of vectors with this curve parameters, they want to prevent it from the day zero. So they have created and utilized another elliptic curve, which is secp256k1. And Ethereum has inherited this approach by also utilizing the K1 elliptic curve. Also, you can see that even Go Ethereum client has some Bitcoin codes inside of the client with C++ to inherit these elliptic curve functions directly. And if we talk about how this K1 elliptic curves be used in Ethereum, as I said, it's generating some private case from some resources and obtaining this public case from private case. And also we obtain our public address, which are the 0x addresses. They are derivated from the public case, and we sign any type of transaction data and or message with our private key. Then we can verify that these messages are coming from specific public address, so that we are able to execute the transactions or messages in different use cases. But we can see that EOAs or accounts are somehow like inside an aquarium, and they are not able to work together with any other ecosystem, more universal ecosystems like other hardwares or other softwares, other internet protocols. And this K1 elliptic curve is not being used in any type of other protocols, mostly being used in different blockchain protocols. So actually, we need to collaborate with other internet protocols or softwares and hardwares to show new use cases or combine two of this world and generate new use cases with Ethereum, so that we can have more universal, more open, more innovative use cases in Ethereum. I'm saying Ethereum, but it includes other blockchains and rollups using EVM. And if we can enable the use of the R1 elliptic curve, we can connect Ethereum to different protocols, such as we can say that most of the mobile devices have an hardware chip called Trusted Execution Environment. Its special name in Apple ecosystem is Secure Enclave. Also, Android has different brands differs in different Android brands. These chips are only working with the R1 elliptic curves to generate some private case, public case, and sign messages. In current case of Ethereum, we are not able to use these protocols natively inside of Ethereum. Also, SSL and DNSSEC protocols are utilizing this R1 elliptic curve in their mechanisms. We are not able to utilize these protocols in Ethereum. And WebAuthn is also a very popular new signing standard for browsers and mobile devices. We are not able to directly use this protocol in also Ethereum. And the most important use cases by utilizing these different protocols, we mostly see them in account abstraction and signature abstraction. In the account abstraction wallets and in the different types of accounts, we have validate signature functions or validate user OP functions in ERC-4337. And in this type of accounts, we are able to abstract these functions and include any type of signature schemas or signature functions or methods for our signatures, so that if we had a chance to use these other internet protocols in Ethereum, we can directly utilize their keys and signatures to send transactions in Ethereum with account abstraction. And I can show a use case with a mobile device. We can think that this mobile device has a secure enclave, which can generate some private keys inside of the hardware. And the most important feature of secure enclave is the keys cannot be extracted from secure enclave, so that it's type of having hardware wallet inside of, or hardware signer inside of our mobile devices. Then we can utilize this key to sign our accounts transaction and directly execute from mobile, and then the users will not need any type of seed phrases or key recovery methods to use their accounts. And I think it's a huge barrier of using Ethereum accounts. And another use case actually came from the ENS community. Nick previously shared an RFP in DNS and proposed utilizing DNSSEC to prove the ownership of Web2 domains and use this domain in Ethereum directly like the ENS domains. And a few months ago, they have presented a work with GoDaddy, which is probably the biggest domain provider in the Web2 world, and they are using off-chain DNSSEC for these domains, but with the CCIP read function, it's another EIP came from also their team, and utilizing this R1 curve natively in Ethereum allows us to make the DNSSEC operations on-chain in an efficient way. And these were the two biggest use cases that I can show before diving into our proposal. And of course, there are some ways to utilize this elliptic curve with other methods without using precompiled contract or without requiring a protocol change with an EIP or RIP. It's not most up-to-date table here, but you can see that the other methods of utilizing this elliptic curve cost too much gas on the EVM. So it's not the most efficient way of utilizing this elliptic curve. Also having very different type of implementation, and these are very low level implementation that developers or users cannot understand very well easily. A way to standardize this work and the functions of an elliptic curve is the most ideal way of using this curve also in a cheap way. And I will also share some resources about these methods. And now there are Solidity, Viper, and Huff implementation also adapting our proposals in interface, but they cost too much gas, and I don't think they are the most secure approach. And there are two methods of utilizing this elliptic curve on-chain by protocol chains. The first way is utilizing EVM Max. It's also another EIP not implemented on mainnet, and it's estimated that it will cost more than 70,000 gas with a possible protocol change. And we are recommending the other way of utilizing this curve. It's adding a new precompiled contract which executes verification operations for this R1 curve. And with our analysis on gas with comparing with other precompiles, we recommend around 3000 K gas for this operation similar to EC recover precompile. And you can see that there are various precompiles on the Ethereum protocol, the L1 protocol now. And the most similar one is EC recover, utilizing the K1 elliptic curve directly on Ethereum natively. And it's a similar precompiled contract with the EC recover. Also, the different rollups or L2 projects have some special subset of precompiled contracts to run their protocols. And you can see this kind of special precompiles from their specifications. And now I can talk about the precompiled contracts specifications itself. It requires 160 bytes of data, including the hash of the signed message, also R and S components of the signature itself, and X and Y components of the elliptic curve public keys. And in the final of this verification operation, it returns 1 in 32 bytes format if the verification succeeds, and it returns nothing if the operation doesn't succeed or there is a failure in type of the data. There were some discussion about applying recovery or verification mechanisms for this R1 signatures, because the K1 elliptic curve has EC recover function on Ethereum, but it's not that similar to EC recovery. It's using a different type of function for a similar elliptic curve. But after months of discussion with different developer communities and also different projects, the fact is recovering these R1 signatures doesn't mean anything for the Ethereum protocol, because when you recover the K1 signatures, you can reach the public address of the account, but it's a different case which is not related with the public address of or any type of address or data natively written in Ethereum. So there is no need for the recovery operation. And also all of these internet ecosystem is using verification operations in their protocol. So having new ecosystem for recovery will be another hard work for this R1 elliptic curve and will not make sense in general. And I have also talked about the gas. We have seen that it is 15% less performant than EC recover. So we projected 15% more gas than EC recovered. That's how we have decided on the gas usage. And it was the specification of the elliptic curve. And I can talk about how we have started work on this proposal, then proposed it as an EIP, then how the things have been involved to migrating this proposal to an RIP. In last year, we have attended an hackathon from ETH Global, and we have been thinking about this use case utilizing the mobile devices as account abstraction signers. And after some research, we found that the most efficient and secure way is preparing a precompiled contract for this operation and prepare the POC demo on the hackathon with OP stack. We have run our own OP stack rollup with this precompile, and it was the first point that we showed some work about this proposal. And we have talked with lots of ecosystem partners, including projects, rollups, and Ethereum Foundation members. And especially Ansgar from the R&D team motivated us to prepare an EIP and show this work to the general ecosystem and see how they react. Do they see it as a valuable contribution to the protocol or not? And before than that, I have never thought about I am in a point that I can write an EIP or work on some protocol chains. But with this motivation, I have consumed lots of content. I have read maybe all of the discussions of previous EIPs, and we have worked with my teammates and with also the contribution with a huge contribution of the ecosystem. We have proposed this change as an EIP in June at last year, and we have attended some discussions in all core devs meetings and in some Ethereum events in the ecosystem and in lots of different platforms. Then we have seen that it's not a point that the Ethereum L1 easily adopt this change, because there had been some rumors about the possible vectors of this elliptic curve. Also, making a core change on Ethereum takes years, but it's a current need of lots of projects in different rollup ecosystems. And then some rollup teams supported us to implement this change before the L1. Also, it was the first times of starting roll calls in the Ethereum ecosystem. now that there were rollup improvement proposal, and it was a regular call which is attended by rollup teams and Ethereum researchers and developers. Again, the roll call team motivated us to move this EIP to RIP and present as the first RIP in the roll calls. And we have collected the support of nearly all of the major rollups and L2 ecosystems, and finalized the proposal with making the last change with the discussion with the L2 teams, and complete the migration of EIP to an RIP with the same number, and worked with the teams to implement this RIP in their protocols. Then I have also became an RIP editor after our working in the first RIP by experimenting the process of preparing an RIP and championing its final position, which is implemented by a few rollups. And another key point in this specification came with a new EIP. The address range of 0x100s reserved for the RIP precompiles, and we have selected the first address of this address range as 0x100, and it was the final selection of our final specification. And these addresses are also reserved in the L1. So if L1 decides on implementing this precompile contract in some date, it will use the same address in all of the protocols. And finally, I can talk about which L2 teams are supporting or implementing this change, also which clients have some implementations on their softwares. The first team who have implemented this change is the Polygon. The Polygon POS chain have launched it with the Napoli upgrades, which have been in a few weeks ago, and you can use on mainnets on Polygon from now on. And ZK Sync has scheduled this change for their next EVM upgrade. It's actually really hard to implement a precompiled contract in a ZK rollup, because with the client codes, they have to write the ZK circuits of the precompiled contract. So it took lots of time to implement this change for ZK Sync, and I hope it will be done in this month, and we will starting to use this precompiled contract in ZK Sync era mainnet. And the Optimism have scheduled this precompiled contract in their next upgrade, which is Fjord upgrade in May. And also it's valid for the base rollup. And I hope we will start using this precompiled contract in all OP stack ecosystem and also Optimism chain starting from May. And Arbitrum and Kakarot ZK EVM chains have supported this change, and they said that they will implement it in future. It was their statement in the roll calls, but they haven't announced the exact dates about their changes yet. But I think it will be very soon for Arbitrum and followed by the Kakarot chain. I will be talking about the clients. We have published the first EIP with the Go Ethereum reference implementation, and also Polygon and Optimism have used this reference implementation on their clients, and it's a final version of implementation on Go Ethereum, but of course doesn't include it in official Go Ethereum branch because it's not in the L1 yet. And Aragon team completed their implementation with the Polygon implementation, and it's ready for the Aragon. And one of the developers from community have prepared the Rust EVM implementation on REVM, and it's working on Red client. It's also ready. And finally, I have seen that Besu team have opened the GitHub issue about this change, and it says that they are working on this implementation for their clients. And also they have this R1 elliptic curve in their native library. So I think it will be a easy implementation for them. And these are all clients that currently adopted this change, and these are the chains that we will see the RIP implementation soon. And I have seen some implementation from non-Ethereum chains like Evmos and Stellar, but I couldn't have much time to explore what are they doing or what they have done with this precompiled contract, but they are following similar specs with us. And I want to show that a similar RPC call for a client who have implemented the RIP. We have the address, and the call data is some kind of 160 bytes of a strings. It includes the hash of the signature and R and S components of signatures and X1 I components of the public key. When we call this address with this call data, we can see that it returns one as true return. And I will lastly show how we can call this precompiled contract on chain. It's a basic static call to the precompiled address, and then we can work with the return data of the static call and utilize it on our on-chain applications. And these are all that I want to talk about today, and would love to have if there are any questions.
It was a great presentation. Thank you so much for sharing all the context of account abstraction, precompile, and use cases. And you talked about precompiled contract specification, story of hackathon. I mean, these are great supportive evidence towards a work in Ethereum ecosystem. Shout out to Ansgar for encouraging you to document this finally as a proposal.
Thank you very much.
So generally speaking, rollups are type of layer 2 scaling solution that aims to increase the transaction throughput. I'm hoping that this standard and any standard for L2 projects will be helpful in encouraging more projects and ultimately helping out the users of Ethereum ecosystem. To touch on some of the other aspects of this proposal, we can move into Q&A. But thank you for already providing a very good context. I mean, like some of my questions are already answered. So let's see what we can take it up anymore. So this started as a EIP, ended as RIP. I understand this has like a lot of history background, some of which you already have shared. What was the challenge of the existing protocol? You talked about K curve and R curve. What was, would you say, the highlight that proposal 7212 wanted to address with?
I think the biggest challenge was to convince the community that it's a useful precompiled contract and there won't be any security risk by adopting this change, and then it will be used by lots of projects and users. Now we can see that there are 10 of precompiles on the L1 protocol, but some of them are not that used in the previous times, and it's confusion for the protocol. And when new rollups are built, or special ZK rollups are built, it's hard to implement all of these precompiles and preserve that they are L1 compatible. And we don't see too many precompiles and new proposals that presents new precompiles. So it was very challenging for us to advocate for a protocol change with a precompiled contract. And luckily, after migrating it to an RIP, the rollup teams and rollup communities were more and more open to adopt this change and test things before L1. But with the migration and also preparing the first RIP and communicating with the rollup teams, it was first for us and first for all of the community, as it's the first RIP, like RIP1. So we have experienced or tried everything by ourselves, and we have seen that how it's going for RIP, and these are also very valuable insights to figure out RIP mechanisms and prepare its mechanisms and documentation. And I'm also happy to be an RIP editor to work on these mechanisms and documentation. We couldn't have much time to think about how these things will evolve for the RIPs and roll calls, but I hope we can think with other RIP editors and prepare these changes.
That's great. I definitely understand this. This was the first proposal, so there are a lot of lessons to be learned, and we perhaps will use some of the good use cases or best practices for upcoming RIPs. My next question is with respect to the curve. You talked about two curves. On a high level, what would you say as like the main distinction between the existing curve and the proposed among R1 and K1, which is more gas efficient? Sorry, I think you mentioned that, but I think I missed that part.
Actually, the amount of gases of precompiled contracts or any client level operations are manually, but we can see that the K1 elliptic curve is more efficient than R1 elliptic curves in terms of CPU usage and other terms. So the precompiles and operations of the K1 curve is more efficient than the R1 curve. And the K point of is that one of the curve parameters of K1 curve is 0. So they are not involved in the mathematical operations. So I think it's the biggest difference for their performance.
Got it. That's helpful. So I'm wondering, like, you talked about connecting internet protocol, like there were so many things that needs to be connected, and we were not able to perform this connection with the present protocol that we have. How does EIP-7212 impact the development of maybe cross-chain interoperability, or maybe able to help us connect with these internet protocol?
Yeah, I think the major use cases will be coming from using these non-on-chain internet protocols directly on Ethereum or rollup itself. We can see new use cases and implementations day by day if we can have a point that R1 curve operations are efficient and secure on-chain. And also I have seen that some new protocols like SWAV and some other blockchains connected with Ethereum has using some trusted execution environments that utilize R1 elliptic curve. I'm not expert on this side, but I have read some articles about these R1 elliptic curves can contribute other type of blockchains to work with Ethereum.
All right. That's great to know. Thank you so much for sharing that. I'm moving towards some implementation, the client implementation that you have shared. I mean, it the proposal mentions that there was Geth and Besu implementation, and you talked about all other clients. I think other than Nethermind and Ethereum JS, almost all EL clients have already implemented it. I wonder if you see any kind of challenges in moving this proposal to the mainnet, because already most of the clients have already implemented it.
I think the biggest barrier is still the social barrier of adopting a new precompile or protocol change. But other than that, I don't see any technical barrier of adopting this proposal, and the client implementation is not that complex or doesn't bring any security risks for the protocol. All of the risks are for the protocols utilizing this precompiled contracts, and most probably if they are using this precompiled contract, they are still relying on these elliptic curves in their other internet protocols or the hardware devices. So it doesn't bring any additional risk assumptions for the Ethereum itself. And I think we can see the Nethermind and Ethereum JS clients can also adopt easily. We have been actually working on Ethereum JS client implementation, but couldn't finalize it. Maybe it's a chance for us to finalize this implementation.
That would be great to have. Generally speaking, Ethereum JS is one of the clients who are always eager to implement most of the proposals. So it will be good to have the implementation of 7212 as well. In the presentation, you mentioned about EVM Max. Maybe perhaps you could talk about the relationship of EVM Max and 7212 and how they are going to support each other.
Yeah, EVM Max is a proposal that allows making complex mathematical operations on chain with a new method. So as elliptic curve operations are such mathematical operations, they can be done with EVM Max, but there is not a direct relation that we have these both proposals on mainnet together and they contribute each other. I don't have on my mind any this type of use cases.
I know Team Epsilon in working behind this proposal for EVM Max and many other proposals for EOF. We hope to look forward to those proposals. Hopefully, those proposals as well as 7212 complement each other and be able to be on the mainnet one day. Talking about being on the mainnet, what do you think as a preparation for a 7212 proposal or to the rollup community that may be needed in order to push this proposal to get included in future upgrade?
I think the rollups will prove that how this proposal is useful and efficient for on-chain applications, developers, and users. And when we see lots of dApps or wallets are utilizing the proposal and everything is going well, and there is a huge adoption of the precompiled contract, also maybe we can onboard lots of new users to rollups with these chains. We can see that it's worth to implement the proposal to the L1, and the best thing to community to contribute to proposal is utilizing the change and show that it's very useful.
Indeed. You mentioned about social barrier as one of the challenges for this to be on the mainnet. I believe community support will be helpful here. And I was going through the discussion tool link. I understand this proposal received a strong support from the community, close to 90 comments, including noticeable contributors like Nick Johnson, was quite impressive. I'm hopeful that this support continues and be able to move this proposal to be on the mainnet.
Thank you very much.
You mentioned that you are an editor, so I would like to pick your brain on editing side of RIP. And before we get into editing part, briefly, can you describe your experience as an author documenting this proposal?
Yeah, as I said, it was the first time I'm preparing a proposal, and it was an EIP. So I have read lots of relevant other proposals, and I have also read all of the relevant discussions on the Ethereum magicians, and these proposals were a huge content and resource for me to understand the Ethereum better, and also understand how should the proposals be. And the magicians forum was a new type of social media for me, that I check new posts daily and see that how the things being discussed on Ethereum years ago and how is it now. I can see lots of people who have contributed the previous chains of Ethereum, and it was a huge contribution of my understanding of Ethereum, and I really love this being of Ethereum that's built by the community. And I think reading the previous proposals and its discussions are the best way to dive into preparing your own proposal. And the magicians forum is great to know the future of Ethereum by seeing from the previous years.
That's right. There had been some efforts towards moving this discussion to Fellowship of Ethereum Magician, and we have received some good words about that. Like it's been helpful for users to just go visit one page about one proposal, and they can get all the information that they need. I hope this is even adopted by many other authors, and they encourage community to leave feedback on Fellowship of Ethereum Magician page. So it will be even helpful for editors to push the proposal. They understand what community feels about it, and yeah, it will be really easier to move towards the next status. The next thing, and the one that I'm very much interested in learning about, is how do you envision the RIP repository as the Ethereum standard?
I think it's a new way of experimenting the chains on the rollups, and reach a huge audience of supporters of the chains. And the rollup teams are more open and innovative to change their protocols. So I think it will be very funny to follow these discussions on roll calls, and contribute to chains, and also see the problems or issues that rollups have, and think about how we can solve it. So I think the RIPs will be very valuable on the next years, but before that, it's not that very popular for now, because there are not that much RIPs, and its mechanisms and documentations are not clear now. So if someone think about writing an RIP and presenting this change to the community, it has an understanding barrier from the first time. So I think we will see the effects of the RIPs in the next months or next year.
I must say it here that it's okay, because we all know RIP is new. Believe me, there are people who still need help for documenting an EIP. So it's a long way to go, but we hope that whatever standards come out of the community, like the proposals which we are receiving here, are the best one, and would be helpful for many other projects to implement them and be able to interop and provide us a better ecosystem that we have today.
Yeah, also I have attended some officers of the cat herders. They were also beneficial for me to get feedback of the community and improve with some changes. I think it's a way to get help. Another thing that I love in Ethereum is when you reach someone, even if they are the most important or famous people in the ecosystem, or if they are very busy, they always respond to you and try to help you and try to respond to your questions and help. So the best thing is asking some questions, joining some discussions in some online working groups, or attending events and finding people and ask questions. These were also very helpful for me, and I'm also always open to help on new evolving proposals, especially RIPs, and help them to find what should they do.
These are great piece of advice for anyone new to the ecosystem. Thank you so much for that. And I'm happy to know that EIP Editing Office R is helpful. We have received quite a lot of good words about it, because for many new authors, especially, sometimes it is becoming challenging, and having one-to-one interaction with editor, that helps. I would like to take this opportunity to even invite you to EIP-IP meeting, which is a meeting for all editors, EIP, ERC, and hopefully the RIP as well. That will help many more people in the community to learn about the RIP process. And I'm hoping that existing editors may be able to help RIP editors to kind of govern some rules around, provide some standards, and then help with the documentation, which would be useful for new contributors in RIP repository.
Yeah, I think it would be great.
We look forward to that. All right, it's time to wrap up. You have shared a lot of information. I find it personally very much motivating that coming from university to getting into the Ethereum ecosystem, a lot of good words around it. I wonder if you would like to add anything more, shout out, or any message to the Ethereum community.
Yeah, I think it's also all for me. Thank you again for inviting me. It was a funny call for me too.
Thank you. Thank you, Ulas, for joining us on PEEPanEIP and talking about RIP-7212. We look forward to seeing the standard getting adopted by more L2 projects and perhaps on the mainnet someday. On this note, thank you to all our YouTube viewers for watching and podcast subscriber for listening to this special episode. Check out the description for more information. In the comment section, let us know if you have any question on this or any other topic, and don't forget to subscribe the channel for more interesting talk. Until next time, keep watching, keep listening, and keep sharing your love with Ethereum cat herders. Cheers.